We'd like to find dy dx, the derivative, and we're going to have to use implicit differentiation because this equation is an implicit function. We can't necessarily solve for y, or it would be really hard to do so. So let's go ahead. Step 1, take the derivative of both sides of the equation. So the derivative of the left-hand side, y cosine of x, y is a function of x, so this is actually a product rule. Think of y as the first function and cosine x as the second function. Product rule says you take the derivative of the first function. The derivative of y is dy over dx. Or you can think it's 1 and then chain rule times dy dx. Anytime we take the derivative of a y, we need to multiply it by dy dx. That's the derivative of the first function times the second function times cosine. Product rule says plus. This time we copy the first function, which is y, multiply it by the derivative of the second. The derivative of cosine is negative sine. That's just the left-hand side. We need to take the derivative of both sides. So on the right-hand side, it's just x squared. We're taking the derivative with respect to x here, so we do this normally, just a power rule. The derivative of x squared is 2x, plus the derivative of cosine y. Well, the derivative of cosine is negative sine of whatever's on the inside, in this case y. But chain rule here, y is a function of x. Anytime we take the derivative of a function with y, we need to multiply by dy over dx by the chain rule. Okay, there's the derivative. Now, dy over dx is our answer. Remember, we're looking for dy over dx, so we're going to algebraically isolate that term. We're going to take everything with a dy over dx, put it on one side of the equation. We'll take everything else on the other side of the equation. So I think this dy over dx, cosine x, I'll just leave that alone. The minus sine y dy dx, I'll add that to the left-hand side. I'll put all the dy over dx's on the left-hand side. On the right-hand side, there's still going to be that 2x, and the y times minus sine term does not have a dy over dx attached, so I'm going to add that to the right-hand side so that everything on the left has the dy dx, everything on the right does not. Now that dy dx is in every term on the left, it's a factor. I can factor it out. This is how we'll solve for it. We'll pull out that dy dx from the cosine of x and the sine of y. Nothing to do with the right-hand side right now. And now we're just one step away. We want to solve for dy dx. We'll just divide both sides by whatever's next to it. This is going to be our answer. And oftentimes you'll see this. These implicit derivative answers are going to look like a fraction, and there's probably going to be a lot going on. It's just the right-hand side all over the left-hand side. And I think we found this derivative using implicit differentiation.